You know, when we look at our planet, we see oceans, rivers, clouds, but what if I told you it's all part of one single massive machine? A giant, interconnected engine that's been running for billions of years, cycling water, controlling our climate, and making Earth livable. So today, let's pop the lid and see exactly how this incredible engine works.
So here's our game plan. First, we're going to get a sense of just how much water we're dealing with. Then, we'll follow a single drop of water on its amazing journey through what's called the Great Water Cycle. After that, we'll dive deep, literally, into the ocean's hidden layers and uncover the story of salt. And finally, we'll tie it all together to see how this whole system acts as our planet's climate control.
All right, first things first. Let's just take a moment to appreciate the sheer scale of it all. You know, there's a reason we call Earth the blue planet. An absolutely mind-boggling 71% of our planet's surface is covered in water. From space, it's the first thing you notice. But hold on a second. If there's so much water, why do we always hear that it's such a precious and sometimes scarce resource?
Well, here's the twist. A whopping 97% of all that water is salt water in the oceans. That leaves a tiny 3% as freshwater. And get this, of that little sliver, most of it is completely out of our reach, locked up as ice and glaciers and ice caps, or hidden deep underground. The water in our lakes, rivers, the stuff we actually use, it is a minuscule fraction of all the water on Earth.
So how does that tiny fraction of usable water get where it needs to go? Well, that brings us to the actual process that powers this whole global engine, the hydrological cycle.
The hydrological cycle is basically water's epic, never-ending road trip. It's a constant loop where water changes form, from liquid to gas to solid and back again, as it moves between the oceans, the sky, the land, and even through living things like us.
Okay, so this diagram lays it all out for us. You can see water moving from the surface up into the atmosphere, traveling over the land, and then making its way back down again. It's this powerful, continuous loop. Let's break down the three main steps.
It all kicks off with the sun. The sun's energy beams down and heats up the water in oceans, lakes, and rivers. This gives the water molecules a little energy boost, enough for them to escape and float up into the atmosphere as an invisible gas called water vapor. That's evaporation. It's the first big step up the ladder.
Now, as all that warm, moist air rises, it gets colder. And just like your breath on a cold day, that cold air forces the water vapor to turn back into tiny liquid droplets. They cluster together around teeny tiny dust particles floating in the air, and when billions of them get together, you get a cloud. That's condensation.
Eventually, those little water droplets in the cloud bump into each other and combine, getting bigger and heavier. At some point, they become too heavy for the air to hold them up anymore. Gravity takes over and splat! The water falls back to Earth as rain, or maybe snow or hail. And that return trip is called precipitation.
And there you have it, the main loop. Evaporation, when water goes up. Condensation, when it forms clouds. Precipitation, when it comes back down. And finally, collection, when it gathers and starts the journey all over again. But where does most of this action really happen?
Well, that takes us inside the engine's main fuel tank, its primary reservoir, the ocean. And believe me, it is way more complex and mysterious than it looks on the surface. You know, it's easy to think of the ocean as just one big, giant tub of water that's pretty much the same everywhere. But that's not true at all. As you go deeper, things change a lot. And one of the biggest changes is temperature, which creates these really distinct layers.
This graph right here pulls back the curtain on that hidden structure. You can see that as you go deeper, the temperature doesn't just get steadily colder. Nope, it stays warm for a bit and then it suddenly plummets. This creates a fascinating three-layer cake structure in the ocean.
So, at the very top, you've got the surface layer. It's sun-drenched, warm, and where most marine life hangs out. But then, you hit the thermocline. This is a crazy transition zone where the temperature just nosedives. And once you pass through that, you're in the deep layer, a vast, dark, and freezing cold world, where the temperature is always hovering just above zero.
But temperature is only half the story when it comes to the ocean structure. There's another key ingredient that helps run this engine, and that's its chemistry. Or, to put it simply, its saltiness. Salinity is really just the official term for how salty the water is. We measure it in parts per thousand. So, if you evaporated a whole kilogram of seawater, the number of grams of salt left behind would be its salinity. And this number is a huge deal, because differences in salinity are one of the key things that drive the ocean's massive globe-spanning currents.
So what exactly is in that salt? Well, it's not just the stuff you put on your fries.
While the main ingredients are chlorine and sodium, which makes sodium chloride, seawater is really a complex cocktail of dissolved minerals including sulfate, magnesium, calcium, and a whole bunch of other elements.
Okay, so you remember the thermocline, right? That zone where the temperature drops off a cliff? Well, salinity has its own version of that. It's called the halocline, and it's a layer where the saltiness of the water changes really fast as you go deeper.
And here you can see that halocline in action. It's that transition zone, usually a few hundred meters down. What's really cool is how this changes depending on where you are. Near the hot equator, lots of water evaporates, leaving the salt behind, so the surface is saltier. But near the poles, melting ice dumps fresh water into the ocean, making the surface less salty than the deep water below.
So, we've looked at the cycle, the layers, the salt, but let's get to the big question. Why does any of this matter? Well, it's because this whole system is, essentially, our planet's climate control.
The impact of this water engine is just profound. It's our planet's air conditioner, using evaporation to cool us down. It's a global delivery service, moving nutrients all over the world. It literally washes the air clean every time it rains. And most fundamentally, it's the absolute foundation for every single living thing on Earth. Without it, none of us would be here.
So, the main thing to take away is this. The constant motion of water, the ocean's layers of heat, its currents driven by salt, these aren't just random facts from a textbook. They are the interconnected gears and pistons of a planetary engine, all working together perfectly to circulate energy and maintain the stable, livable climate we all depend on.
This engine has been running smoothly, keeping our world in a delicate balance for eons. It's ancient and powerful, but it's not indestructible. And that leaves us with a really important question to think about. As our world continues to change, what are our actions doing to the gears of this vital planetary machine?